So section 14.3. This is going to be adding and subtracting rational expressions. And there's a few rules we have to talk about. So when we add or subtract fractions, the denominators must be the same. All right, and then once they are, which we call the least common denominator. And the way we do this is we multiply by the missing factors. We combine the numerator. We also use parentheses if subtracted. Just give you a second to copy that down, and then we'll get right into some examples. All right, so what I'm going to ask you to do is we will simplify the following. And first one is 8x plus 7 over x minus 5 plus 9x plus 1 over x minus 5. As you can see, the denominators are the same. So what we could do is we could combine the numerators. So what this means is we're just going to write this as 8x plus 7 plus 9x plus 1 all over x minus 5. And then 8x and 9x is 17x plus 8 over x minus 5. So once our denominators are the same, which they were from the start here, we could just combine the numerators. Similarly, if we had a problem like this, where it's 5x squared plus 11x over x minus 1, and we subtract 5x plus 11 over x minus 1. The denominators are the same, but this is a subtraction problem. So what we want to do is write 5x squared plus 11x minus 5x plus 11, all divided by x minus 1. The problem with this is you're subtracting that fraction. So you're subtracting this whole thing. So we have to account for that by putting this in parentheses. And we get 5x squared plus 11x minus 5x minus 11 over x minus 1. This just gives us 5x squared plus 6x minus 11 over x minus 1. That would be the answer. A common mistake for a problem like this is right here. People would forget the parentheses, and obviously that would be the wrong answer. All right, so now what I'm going to ask you to do is we'll do a different type of problem where I ask you to find the LCD of the following. When we're talking about LCD, there's a couple things I just want to talk about. One is the LCD with the number is we go with the largest number that all can divide into. And then as far as the variable, we go with the smallest power for all the letters in common. All right, so let's take a look at a few examples here. I just want to know what the least common denominator is. So what if we had 2 over 4x squared and 6 over 10x to the third? So we're not concerned at all about the numerator. We're just looking at the denominator here. So we want to try to find the largest number that all of the denominators can divide into. So let's see here. This shouldn't be largest. This should be the least or the lowest. So just fix your notes. This is the lowest number that all can divide into. So the smallest number that you could divide by 4 and 10 would be 40. And then the variable, we're looking for the smallest power of all the ones that are in common. So we have x to the second and x to the third. 40 x to the second would be our least common denominator. Wait. Oh, yeah. My note's wrong. Yeah, my notes are a little off. Yeah, I'm sorry, guys. Yeah. It should be the largest. Here, just fix your notes. I totally screwed this up. When we're looking for the least common denominator, we want to find the smallest number, but the largest power. So 40x to the third. What we would do to get the least common denominator for these fractions is we'd multiply this by 10x and this by 10x, and we multiply this by 4 over 4. That would give us the least common denominator of 40x to the third for both fractions. All right, let's take a look at 2 over x plus 3 and 3 over x minus 4. the least common denominator would be, you definitely need a factor of x plus 3 and an x minus 4. And then in order to make it work for these to get the common denominator, you'd multiply by whatever's missing. So you'd multiply this by x minus 4 over x minus 4. You multiply this one by x plus 3 over x plus 3. But that would be the least common denominator for this problem. What if we had 5 over x plus 2 and 7 over 2x plus 4? In order to find the least common denominator, sometimes what we have to do is factor first. So we get, this is just going to stay 5 over x plus 2. And this is going to be 7 over 2 times x plus 2. So the least common denominator, we definitely need an x plus 2 because that's in both fractions. But we also need a factor of 2. So the way you would get the least common denominator here is you'd multiply this by 2 over 2. Right, and then what if we had 2x squared over x minus 4 to the second power and 5x over 8x minus 32. In order to figure out the least common denominator, first thing we have to do is factor. And we just want to factor everything all the way out. But what I mean by this is this fractional factor to be 2x squared over x minus 4 times x minus 4. And this fractional factor to be 5x over 8 times x minus 4. So we definitely need an x minus 4. This has an x minus 4. This has an x minus 4. We definitely need another x minus 4. And we also need an 8. So what we would do to get the least common denominator for both of these fractions is you'd multiply by whatever's missing. For the one on the left, you multiply by 8 over 8. The one on the right, you'd have to multiply at top and bottom by x minus 4 over itself. So the question was, are both x minus 4 being multiplied by 8? And the answer is just one is. So it's kind of like if I asked you what's 2 times 3 times 1, like 4. What you would do is you would say 2 times 3 is 6, 6 times 4 is 24. You're not actually like multiplying like that. Does that make sense? So what you would do is you'd multiply these two, get the answer, and then multiply that by x minus 4. Good question. And then one more of these. What if we had 5x plus 1 over x squared plus 3x minus 4 and 7x over x squared plus 2x minus 3? Well, in order to figure out the LCD, we have to factor. This would factor to be x plus 4 times x minus 1. Spent a lot of time on factoring. This would factor to be x plus 3 times x minus 1. So for our LCD, we definitely need an x minus 1. We also need an x plus 3. And we also need an x plus 4. And then just like before, you'd multiply by whatever is missing. So for example, the one on the left, you'd have to multiply top and bottom by x plus 3 over itself. The one on the right, you definitely need an x plus 4, so you'd multiply by x plus 4 over itself. And the last type of example for this section, I'm just going to ask you to rewrite the rational expression with the given denominator. So for example, if I gave you 13 over 20y, what I'm asking you to do is figure out what you'd have to do to get a 40 y to the third in the denominator. Well, in order to make that happen, you'd have to multiply by 2y squared on top and bottom. And then that would just turn into 26 y to the second over 40 y to the third. That's what you'd have to do. Question is, can you simplify it? The answer is yes, you can simplify it, but it's not this problem. That's not what we're looking at. Next, what if we had 8 over 4a squared, and we're trying to turn the bottom into 12a squared b to the third. Oh, we would definitely have to multiply by 3 to get 12, and we'd have to multiply by b to the third. So I'm going to do 3b to the third on the top and bottom. And we get 24b to the third over the bottom, which is what we wanted. And then one more of these. What if we had 5y minus 1 over 10x squared minus 25? And we wanted to try to make the denominator 20x squared minus 50. Well, to get that, we just have to multiply top and bottom by 2. And we get 10y minus 2, and the bottom would be exactly what we wanted. All right.